Okay, in this concept, we're going to look at the relationship between the discriminant and the roots. Now, the discriminant is the expression that's inside the square root in the quadratic formula, so which is the b squared minus 4ac. Remember, the quadratic formula is x equals minus b plus or minus the square root of b squared minus 4ac over 2a. Okay? Now, so the discriminant is this expression right here, which is inside the square root. Okay? Now, the value of the discriminant can be used to determine the number and the type of roots of a quadratic equation, even before solving the entire, formula. Okay? Here's an example. So given the quadratic equation, ax squared plus bx plus c equals 0, and a is not equal to 0, again, standard form for the quadratic equation, there are 4 conditions for the discriminant. Okay, there are 4 instances of the discriminant which give us 4 different pieces of information on the number of roots, how many roots you have, and the type of roots. Okay, real, rational, irrational, complex, etc. The first condition is if the discriminant, b squared minus 4ac, is greater than 0, and if it is a perfect square. Okay, so if these 2 conditions are correct and true, then the quadratic equation has 2 real rational roots. Okay, so 2 real roots that are rational. Let's look at an example. Describe the number and type of roots for 8x squared plus 18x minus 5 equals 0. So again, using the noting the coefficients, right? We have a equals 8, b equals 18, c equals minus 5. Calculating the discriminant, we get b squared minus 4ac, so we get 18 squared minus 4 times 8 times minus 5, again, and then evaluating it, we get 484, or 22 squared. So since the discriminant is 484, which firstly is positive, and secondly is a perfect square, right? Therefore, there are 2 rational roots for this quadratic equation. Okay? The second condition for the discriminant is if it is greater than 0 and is not a perfect square. Okay, so the first condition was it had to be positive, greater than 0, and a perfect square. Now it's positive, but not a perfect square. Okay, so in this case, the quadratic equation would have 2 real but irrational roots. Okay, so 2, just like the previous condition, 2 roots, but they are irrational. Let's look at an example. Describe the number and type of roots for x squared plus 16x plus 4 equals 0. Again, noting the coefficients, we have a equals 1, b equals 16, and c equals 4. The discriminant, b squared minus 4ac, gives us 16 squared. B is 16, so 16 squared minus 4 times a, which is 1, times c, which is 4. And then evaluating this expression, we get 240. So 240 is a positive number, so that means we have 2 roots, but it's not a perfect square, so that means we have 2 irrational roots. Okay? The third condition for the discriminant is if the discriminant comes out equal to 0. In this case, the quadratic equation has 1 one real rational root. Okay, so a single real rational root. Let's look at an example. Describe the number and type of roots for this quadratic equation. 4x squared plus 4x plus 1 equals 0. So noting the coefficients, we have a equals 4, b equals 4, c equals 1. Evaluating the discriminant, we have b squared minus 4ac, so b is 4, so 4 squared, minus 4 times a, which is 4, times c, which is 1. So we have 16 minus 16, which is 0. So in this case, since the discriminant is 0, there is one rational root. And the fourth condition for the discriminant is if the discriminant comes out less than 0, in which case the quadratic equation would have two complex roots. Okay? Complex, imaginary. Let's look at an example. Describe the number and type of roots for this quadratic equation. X squared plus 3x plus 8 equals 0. Noting the coefficients, again, we have a equals 1, b equals 3, c equals 8. 1, 3, and 8. Okay? Evaluating the discriminant, we get b squared minus 4ac, which ends up giving us minus 23 in the end. So since the discriminant is negative, there are two complex roots. Okay, here we have some exercises to practice this. Please pause the video, work on these, and come back for the solutions. Okay, let's look at the first exercise. We have 2x squared plus 6x plus 8. Describe the number and type of roots. So here we have a equals 2, b equals 6, and c equals 8. So our discriminant is b squared minus 4ac, which is equal to 6 squared minus 4 times 2 times 8, which is equal to 36 minus, so 4 times 8 is 32, times 2 is 64, right? So 36 minus 64 is equal to minus 28. Okay, so since the discriminant is negative, less than 0, we have two complex roots. Okay? Let's look at the second exercise. Determine the values of k that will make the roots of the equation equal. So ky squared minus 12y plus 9 equals 0. K here is a constant, right? But the trick is to determine what values of this constant will make the roots of the equation equal. Now, what does that mean? Well, that's essentially a tricky way to say, well, give the equation a single root, right? Because how else could the roots be equal? Well, if you had a single root, right? Because if you ever got, the same root twice, I mean, you couldn't get the same root twice. It would be a single root, but then, again, it's a trick way of saying there would be a single root. And which condition of the discriminant is the condition that means that we have a single root for the equation? Well, that happens when the discriminant is equal to 0. So we need to evaluate the discriminant and set it equal to 0, and from there we can determine the value of k. Okay? So our a here is equal to k, right? B is equal to minus 12, and C is equal to 9. So B squared minus 4AC is equal to minus 12 squared minus 4 times K times C, which is 9, which is equal to 144, minus, so 4 times 9 is 36K. I need this to be equal to 0, so that I'll have a single root, right? Or roots that are equal. So 144 minus 36K equals 0. 144 equals 36K. Again, I added 36K to both sides. So now I can divide 36 to isolate the K. So I have K equals 144 over 36, which is essentially equal to 4. Okay, so for a value of K of 4, I will have roots that are equal or a single root to the equation. Okay, let's look at the next exercise. So determine the values of K for which the roots of the equation will be imaginary. And remember from the conditions that we discussed for the discriminant that we get imaginary roots if the discriminant is less than 0. So here, we're going to follow a similar process just like we did in exercise 2, but we're going to set an inequality. Okay? And we need all the values of K that are less than something or greater than something, right? So we're going to have a range of values. It's not going to be a single value. So let's see what this is going to look like. So our A is K, our B is minus 10. This is 10, not 6. 10. Our C is 5. So we have B squared minus 4AC is equal to minus 10 squared minus 4 times K times C, which is 5, which is equal to 100. So minus 10 squared is 100. 4K times 5 is 20K, so 100 minus 20K. And this needs to, this whole expression, right, the discriminant, needs to be less than 0. So this is all we need to solve. Just solve this inequality for K, and this will give us the values of K for which the roots of the equation will be imaginary. Okay, so let's solve. So if we add 20K to both sides, we'll have 100 is less than 20K, and then if we divide 20K, divide both sides by 20K, so 100 divided by 20 is 5, so K is greater than 5. So this is our solution. Okay? All the values of K for which the roots of the equation will be imaginary are all values K greater than 5. Okay? So 6, 7, 8, 9, 10, 100, 1000, etc., etc. All right? Hopefully this was clear. This is it for this concept. See you in the next video.